Hello world. A lot of data, a little information. We had found ourselves with this commonly. That's why we present you the tutorial video how to use Gold Parser. Obviously, first of all, we need the tool. For that, we could search by using any web browser this direction: www.devincook.com/goldparser, or to Google Gold Parser and the first answer will be the official site. We go to the download area and select Builder and Tools. Then we click the first option in order to download the Gold Parser Builder. Leave it in a place that you can remember. We are leaving it in the desktop. Okay, before the installation, we download also the engine. Forwards, we explain why we are going to need this. So return to the download portal of Gold Parser. Go down in the page until you find the engine section for the different languages in which a grammar can be generated. Due to this example will be made in C#, we go to this link. We arrive to a page that looks like this. It shows several engines from which we select Kalita engine. Due to the wide disponibility in terms of the use of C# and F#, we're going to need only the libraries, so we select the first option. Just like we told you in the previous file, leave it in a place that you can remember. Again, we are going to put it in the desktop just for convenience. Now we can proceed to install the application. It's as simple as installing anything on Windows. First, unpack the file that you first download, goldparserbuilder.zip. Once you have unpacked it, double-click the setup.msi. It shows a welcoming message, so simply hit next. Then it asks if you want to change your destination folder and who can use it. Plus, the default options will be fine, so place the modifications if you want to and then hit next. It asks for confirmation in order to be able to start the installation, and if you are agree, hit next, and if you aren't, you can return to the previous steps. When the installation is over, it presents a success message like this, so hit close. Now that we already have the tool installed, we head to the interesting part, code. Let's open the Gold Parser Builder application, and we already can see the editor. Here we already have prepared this grammar, so for this tutorial matters will be the grammar of SVG, and then with the Gold Parser Builder help, generate and interpret for that language. Basically, the grammar of SVG is the same as the grammar of XML. This explains its cleanliness. Now, let's explain the nomenclature we are going to use within the editor in order to develop our grammar. In order to be able to unfold of a quickest way, we are going to divide this file in three sectors: header, scanner definition, and parser definition. We test the grammar to see it compiles, and we are going to see in detail every one of the sections. In the header, we have a set of directives that are going to call metadata, or parameters. It's not vital for the function of the compiler, but yet important in order to have a good inner documentation of our grammar. Within this data of the header, we want to emphasize these two, case-sensitive and star symbol. Case-sensitive refers to a distinction between uppercase and lowercase characters. So because this is a basic example, we're going to make no distinction between characters. So we set this parameter in false. A star symbol refers to a non-terminal symbol with which the grammar will start, or how we categorize it in this tutorial, the beginning of the parser definition. A scanner definition is where we define how the terminals we are going to use within our grammar are composed. Watching our first regular expression, we can identify that sets of predefined characters are used, and we are going to call them sets. Gold Parser already have predefined sets such as letter and alphanumeric that by their names can tell that the first one refers to all the letters there are, and the last one refers to all the letters but also all the numbers in only one set. In order to start any grammar in Gold Parser, the VNF or Backus noun form nomenclature must be written. What are we trying to say with this? We're trying to say that the non-terminals must be written between the signs less than and greater than. Terminals are defined with an ID that refers to a sequence of characters that express their identity. Strings of characters can be used as terminals too, but they have to be inside a pair of single or double quotes. Now that we have our grammar finished, we must select Project, Create a Skeleton Program, and within the dialog box we select C# Kalita Event Base. What changes with the other one? It changes because every action will be handling as an event, and we just have to manipulate the event handler. This will create the respective .cs, and it can be corroborated by us. With this, we conclude the use of the Gold Parser Builder tool. Plus, the result deployed is not a 100% functional compiler, so for this file to be transformed into an interpret of SVG, we create a new project in Visual Studio, or well, C# Express, just like we are going to do. We are going to create a simple interface. Now we go to the Solution Explorer. We right-click it and select Add, and from this submenu we select Existing Item. This will show a dialog box from which we can take the file we create with Gold Parser Builder. So now C# Express will create a copy of this file, and upon this copy we are going to be working. We need the code that we generate with Gold Parser Builder. But first of all, we must have the compiled grammars and the engines. If we don't have those, the parser won't function. To accomplish this, we go to the place we saved them after we download them. Then we are going to unpack them, and there are going to be 4 files, from which we only going to need the ones with the DLL extension. So we return to C# Express and go to the Solution Explorer. We right-click it and select Add Reference. It shows a dialog box, so we select the Explorer tag and we put the directions of both DLL files. This should be Kalita Lib and Gold Parser Engine. Now let's see with more detail the structure of our skeleton, so you can make yourself an idea and be able also to use our source code to develop your own compiler solution. The Generate Skeleton by Gold Parser has the method PrivateObject in which we look up to the non-terminals we are interested in getting a value, for example with the IDs, numbers, and practically any literal. The object we return in every option will subsequently be helpful to the semantic analysis. Another method the generated skeleton possesses is public static object create object. This method we can leave it as an static method. We have that all terminals and non-terminals possess the user object attribute, in which we can store any type of data. In order to access to the user object attribute from ID, we do as follows. Tokens user object. This is the index that is placed in the object list. Tokens corresponds to the index the production has. In the example, ID corresponds to the 0 index. Equal corresponds to the index number 1, and attribute corresponds to the index number 2. The method that is used for the creation of objects inside our code will be public void render object. This method takes as parameters the name of the object, which it could be rect or circle, and a list of attributes. In this way, knowing the type of object, we can now assign the attributes and add it to our drawing area. In the skeleton, we found two methods for recovery from errors. The lexical errors will be reported to the private void token error event method, and the syntactical errors to the private void parse error event method. Now let's see the application run. First of all, we select the input file, which is a SVG file. We can see now how our compiler works. This is the code of the example input file. We watch how it works again. And this is it. We hope this tutorial has been helpful to you.